All right, good morning, everyone, and welcome to today's class where we will dive deep into a very important topic in very important Python library. It's one of Python's library. So we'll be how it is used, what is it, and the area it is being used. So without wasting time, I would want to proceed first with the explanation. So NumPy is a Python library, just like any other library, but today we'll be talking about NumPy, and it was created in 2005 by Oliver, and we get to see that. So it performs numerical calculations, and it's generally used for working with arrays. So NumPy is is that short for numerical Python. So NumPy is short for numerical Python. This is such as linear algebra, random number generations, which can be applied to arrays and all of that. So in other languages like C programming, JavaScript, and the rest, we have something called arrays. But in Python, we have what is called list. Okay, so this is where NumPy comes in. And before then, why use NumPy? Why is it that necessary? Do we really need it since we have lists and this just comes? So how does it work to start with? Why do we use it? So we use NumPy in fields like machine learning, which of course it's what concerns us, and other areas that it is used are data science, image and signal processing, scientific computing, and quantum computing, and all of that. So the bigger question comes: why NumPy? Why do we use it? Why NumPy? All right. So I want to quickly mention some of the why reasons you should use NumPy. So first, it is for fast. It is for fast execution. As compared to list. So maybe I'll now compare and contrast. This is NumPy, and I'll go up here and I'll use it for list. So I'll compare that for NumPy and for list, of course. So it is very it has fast execution because it works with arrays. But when it comes to large operation, Python list it's not optimized enough to handle that. So it's not the usual arrays or the list where we have few elements or few list items, maybe 10 or 5. This is where we talked about thousands, millions of data items. So NumPy is well optimized for that. And since they use array, they are optimized for complex mathematical and statistical operations. So operations on NumPy from Survey is up to 50 times faster than iterating over Python lists using loop. All right. So some of the reason is that it uses a special data structure called arrays, and it's created using this NumPy, though it is partly written in Python, but some of the parts that has to do with memory management and efficiency are built with high performing language rather, like it's built on C programming, which is a low level programming, and it's very fast in terms of execution. So it's used various library. These are some of the reasons we use NumPy. NumPy is heavily used with various libraries like pandas. We get to see them maybe next class, but it's work with pandas. It's work with CPy. Don't get scared. Everything will be broken down, and the circuits learn. So that is that. So for this NumPy application is very fast compared to list. For memory, it is very fast, and here is very slow. List use loops, but in NumPy we don't need that. So that is how it is. So that was just a very deep overview of what NumPy is. I've mentioned that it is short for numerical Python, and it is a Python library. It uses a continuous memory view, so that is why it is very fast and use a very optimized data structure, which is the array, and it's heavily used with some libraries like pandas and the rest. So that is that. For this class, I would want us, yeah, because you need to import pandas if you're working with VS Code. You need to import pandas on your machine. And to do that, since you have Python installed, you need to check for pip version just to know that pip is installed on yours. So you can run this command now on your system. Everybody's joining the call with your system. So if you are to run this command now. Everyone downloaded Python. But to get here, just for those who will be watching the recording later, you must have Python first installed on your machine. Then before you have this pip. So since this NumPy is a Python library, so you'll be using pip, not download from your machine firstly. And then again, that's where you use this command pip install NumPy. So if you have all of this, you should be able to install NumPy successfully on your machine. But just in case you're having issues with today's, you're having issue to do this, for the sake of today's class, which I would love you to practice along with me, I now make this cloud-based editor available. This is what I'll be using, this cloud-based editor. So it is called Google Colab. So you can hit your browser and hit this, type Google Colab. Once you type Google Colab, it should be out and you have this. So what is this Google Colab? Just a very brief introduction. So Google Colab is short for Google Collaborator. So we can either call it Google Colab or Google Collaborator. So it is a free cloud-based Jupyter Notebook environment. Jupyter Notebook is one of IDE code editor where you write, you run, and modify your code, just like VS Code. But it's optimized for machine learning, data analysis related work like that. So it is provided by, I've mentioned that it is a cloud-based Jupyter Notebook environment, which is provided by Google. So what it does, just like your VS Code that we have been using, it allows you to write, run, and share Python code in a web browser. So why is it needed? No setup is required because it's, as some of these libraries come inbuilt. So it is used popularly among data science scientists, machine learning engineers, students, researchers, and all of that. Why use it? So you can use it and write your Python code, upload and analyze your data sets, create and plot your graph of visualization. You get to see that as we proceed. And for this today's class, since it already has NumPy and other framework like Pandas, where we'll be using them as we proceed, TensorFlow, PyTorch, and all of that installed. So it will save you the stress of using this, but if you still want to use your VS Code, you can go ahead and use that. So I'll be using two for this, the two of them for this class. All right, so that is that. You see how to create an array using NumPy. And what are arrays? That talk about that. I'll say we talk about array first, NumPy array creation. So an array allows you to store a collection of multiple values in a single data structure. So the NumPy array is similar to that of lists. You see, I'm comparing it with this, but with added benefits such as being faster, all right, and more efficient than your list. So NumPy library provides various methods to work with data, which leverages all these features with multiple technique. So yeah, let's hit over. Have you guys all accessed this? You can hit your browser and type Google Colab, just like that. See, it's already coming out. So it is, have you seen, this is it. So if you hit that, you should have your own copy. Hope I'm still very much together in the class with everyone. All right, all right. So you hit that and you have your own. Once it's done loading, you should have access to it. Now, let me just show you a very simple that we are building from what we've been doing. So from here, you have to, well, of course, you will do this here. You don't need to install it for now, but after the class, you can go and install it on your machine. So using here shouldn't give you an install. I think it's done. Okay. So have you seen it's downloading and it's telling Google Collaborator, short for Google Collab. So if you hit new notebook, of course, that is what we use. So while it's loading, let me explain this. So you have import numpy. Now there are things you need to note here. Is firstly, let me complete it. Import numpy as np. So what this does, that this is a kind of alias. This NP is a kind of alias for NumPy. This N stands for num and P stands for pi. So it's nothing, it's set for alias, which is like a very conventional best practice. Okay. So which will help you maybe create an array. I'll still show you another way. Let's say array 1 equals to, I told you this is an assignment operator. NP dot the array keyword. This one now, you see, it's different. This one is a variable name, but this one is a constructor that helps you create an array. So just like a list, you know, you need this, and you know, this square brackets differentiate a list from a tuple which uses parentheses. I'm trying to take your mind back and how it's related to what we are doing today. Just to do this for, and that is that. So if I want to print array one, so you either load it from here or you hit Control plus Enter. See, cells has been executed in this session and all of that. So I'm printing it and it is loading. So you see that it has given us our result. So this is one way of doing it, which is the best practice, and we will be doing that. So, but if you don't want to import it with this, of course, you can always edit your code again. If you don't want to import it with just import numpy, of course, you know what you'll be doing. Like you'll be typing a lot because you'll be typing a lot. So you have to call numpy again. All right, numpy dot array for this. So this is a list, first of all. Okay, so before I get to that, let me finish this. So with this, if you're not using the alias, you have to all the time type numpy dot whatever method you want to do, numpy dot whatever think you want to expose. So let me run that to see it still give us the same output. So why pass through the stress if you can have a shorter way of doing that? Numpy as np. Right, so it's already showing this because we change it. So we change everywhere np, and yeah, all good. So if you run it again, you see we have our output. Okay, so that was to illustrate the importance of using the alias. Hope my network has not disabled me. All right, all good, all good. So from what we load, when I type of Google app, you see it out. So you can start practicing with me here. All right. You can start practicing along with me. So I'll clear that because I'm already using this. Okay. So let's first of all create a list as we normally do before I'll now create a numpy array using the list. So let's do it as usual. I could call it list one, and I'll assign it to, of course, you know, what we used for our list. So I could say 2, 5, 3, 1. Okay, so we create our list this way. And just like when we did tuples, okay, before we can do or modify things in tuples as against list, we needed to create a tuple, then convert it to a list, modify it, and convert it back to a tuples. Almost the same thing here is what I want to experiment with, but not in that logic, not in that perspective. So firstly, I want to have created a list here, and I can come here and create array. I'll be using this array one for short. You can name it anything, all right? So array, of course, I'm bringing my numpy, which we in of this np array of list one. So we are now converting this list one now to array using this keyword. All right. So I want to print out this, and you will see. So I'll run it here. And of course, you see 253. So I wanted to link it to what we've been doing weeks back. I've been telling you that we'll be building from the foundation. We'll be building from what we've been doing so far. So just to explain this, because after this part I'll be a bit fast, so let me go over it. So on my screen here, I first import NumPy, which is NumPy as a library. Of course, you know it's a Python library, so I first import it as NP. And I'm telling you that this NP could be something else, could be Sandra, could be Glory, could be X, but this is the conventional best practice. And of course, yeah, it's this way because N is supposed to stand for the num and P for the line. And then again, I created a list called list one when you notice in the code. So the magic happens at this particular line where I converted this list to a numpy array, where I say numpy dot array. I call this dot list one, which is the name of our variable. And at this other line, I print it out. So I believe that is clear. Any question from here before I proceed? Because going forward, I will be a bit fast. So I needed you to get the syntax, get the basic, get the logic, and remove. I'll be leaving it for 2 seconds for you to see what is there, try to deduce something out. If you have any question, you do it under that 2 seconds. If no, we proceed. Okay, so in the absence of no question, I will quickly want to make another differences between list and array. So unlike list that can store multiple data types, of course, array can only store data of similar data types. All right. And maybe you'll not be seeing me use strings and all of that because I made mention that this numpy is short for numerical Python. Okay, so everything numeric, everything, all numeric functions, applications is what we'll be doing. Okay, so I get that is clear. So from here, oh, sorry, I didn't take you over how to use the Google Colab. So from here, you can make your settings here. You can hit your settings here, and theme. I'm using adaptive. It is not so bright. It is not so dark, but you can change it to either a light mode or you can change it to dark mode. So for the sake of people in the call, I'm using this adaptive to save my eyes and also help people in the call to, have a very clear view of that. So you could come to editor. Of course, you could see that when I was typing right at some autocomplete, I enable AI assistance to save me some time from typing. Of course, you can also link your GitHub here, authorize GitHub, the same thing we did to VS Code. You can link it here and push from here to your GitHub directly. So most settings come to editor where you want to set the font size. You can enable it. Me, I left it at monospace because you saw that it's makes the fonts very readable. And indentation in spaces, I want to leave it at 4 because that is Python default indentation. And all other things, maybe you want to show line numbers, enable code feeders, and all of that, which I don't really need. So once you are done with that, you can hit save and everything is saved. So another thing is that if you hit this run now, it will show you start the session because I have the interrupt code execution, but I will show you more things you can do with this front as well and start typing. And tools, these are from I hit setting from here, but you can also access your settings from here, and maybe some of your keyboard shortcut you don't maybe want to, like example, if you want to run your code like I did here, you can hit control in your keyboard and plus enter. So once you hit control at the same time and hit enter, it will run the code automatically. So now when you come to runtime, could have run all code, which will run everything, run code before. When we type, you see that maybe I didn't mean we have. Hope I'm still on the call. All right, all right. Then we could run a focus cell. Maybe you hit on it and come there, and or you could run a particular selection. You could run code below. Maybe I have another application here. I will run it below this one. I can even interrupt my execution, restart. I can disconnect and delete the runtime and all of that, whatever you want. So insert. So you can insert code cell, text cell, and all of that. I'll be using them so you see how I'm using it. So you can hide code, you can hide output, and all of that. So edit, you can select all cells and maybe do whatever you. So like this, find and replace. Let me quickly do it. I can find maybe list one. I can find list one, right? And replace it with who is on the call and replace it with my name, UD. Have you seen? So it has highlighted all list one in the cell. All right. So wherever it finds list one, it will replace with my name, UD. So I'll say replace. Yes, I'll say okay. Have you seen that all the list one has been replaced with UD? Google Colab is very simple to use and all of that. Someone just unmutes. I do want to ask question, or if that is a mistake, please kindly mute. Esther, do you want to ask question? If no, please kindly mute. All right, so that is that. You can change it to another thing. Maybe find this array this time. Array one, right? And replace it with my name anyway. You did not, right? So if I click on replace all, I'm seen that all array one has been highlighted. So if I hit on replace one and okay, see that all the arrays has been replaced with my name. So that's for that undo. So I can do undo all, replace all. And you see it has gotten back to the edit. I can undo again, and we have our list, and just like what we have. So you can select all cells. Maybe you want to delete them, select sections. You can copy code somewhere and paste. You can find and replace. We did that. Find previous, anything. Then when it comes to file, this your Google Colab is directly linked to your drive. I don't know if you can see this drive icon here. So you can locate your file, your drive, and directly save your code on your drive. New notebook in drive, you can open it the same way we used to open from our desktop and open with code to access our VS code. You can do that here. Open notebook, you can open another notebook here. Like everything here is notebooks. You can open, you can upload notebook from either your machine or your PC. You can rename your notes, you can rename your notebook. So if I come here, you see here it will be highlighted. I'll call it numpy class, right? So if I hit enter, you see that it has been replaced. So I can move it, trash it, save a copy in drive, save a copy at GitHub, and save a copy here. So each time, just like your VS code, you have to save your your code, all of that. So if I save it, have you seen it's showing you saving. So once it's done, so that is just a successfully saved. So that is just some of the things you can do. Find and replace short for that. Code snippets. Could add short code snippets to do, and yeah, here is your files. Okay, so that is that. Get back to where we were. So now for this variable, if I hit here, you see it will explain all the things that I've done here. It's telling me that I have two variable names. You can see variable inspector. So you could see that I'm having two variable names here, list one and array one. It's telling his list one and array one. So what data type? This one, array one, is ND array. This ND array is short for n dimensional array. You get to see more of this. You use this as we proceed, and it's telling me is of shape 4. This shape 4, we see 1, 2, 3, 4. But when we proceed, we get to talk more about row and column and all of that. And the value, you could see that the array has 2, 5, 3, 1, and you are seeing 2, 5, 3, 1 here. And for the second one, you could see list one. The type is list, and it has four items of. In our list class, I told you that each member of the list is called an item, so it's trying to make us visualize that. So I think we'll be using this Google Colab so much because it helps us visualize what we are doing and all of that. So you can take that on. So you could come here and print just to differentiate between this what we've been doing. You could print type. This will be happening melodies type of array one, and I'll print what we've been doing before. Print type. Just help me type of is what we've been doing. So if you're not look confused, type of list, type of list one. So if I run myself, you could see that type of array is of ND array, and just don't bother about this ND array, but I told you that it is short for n dimensional array. This n can replace any numbers of arrays. We have multiple dimensional arrays and all of that. So, and of course, we've been doing this, are very much familiar with this. So, okay. So that is just a quick run through, a quick overview of this. So going forward, I'll be a bit fast because I believe you now understands the basic, the syntax, and some rules behind it. So yes, if you want to add another code cell, you can either click here. Have you seen the start typing and all of that? So I can take it up and I can take it down. If I take it up, it will be before this one, but I don't want it. I want it here. And you can delete it. So if I delete that, it's gone. Or you hit the text cell where I can write next anything. Next is array rating array, anyways, using what let me find any method, maybe np dot zero, the zero method. Let me work with that. So I can highlight all of these and bold it here. You see that it is bold, or I can italicize it, and all of that. Can have a list here just to explain and that. So that is that. And you can take it up, you can take it down. So I need to add another code cell. All right. So next I can want to say, let's still use my, this time I will say maybe array2 or anything. Array2, and I want to assign it to np. I want to use this method since I've already set it out, np dot 0. So what this will do for us is that it will create array, all right, with 50 field, all right. So let's watch, and of course I've print array too. So if I run my cell, have you seen it has created an array field of 5 items filled with zeros. All right, so I'm not going to delete it because later on I will want to push to our GitHub and all of that. So I'm leaving this here so that maybe if you want to visualize what is going on here, you can do that. So maybe you are looking here and you seems to be a bit confused. You can just come to the left side and try to visualize what is going on. This is array 2. If I print type of array, you see that it is of this and it has 5. Don't worry about the shape. You will see the shape method as we proceed, and the value is of 0. So you have to look here and to look here in Dimension. All right, so let's try another method here. I'll hit another cell. Another method where I'll use the range function. All right, so maybe let me be using comments. The range, using the range, arrange np.arrange function, right? So I would say maybe array 3. The next array 3. Use arrange let me see this 5. Just to be a bit more descriptive, I will do something here using np.arrange. I want to put 5, and outside of it, I will call what arrange 3. That is our variable name. Arrange, is that the spelling? I've overspelled it. 1 R. Okay, so I'm calling this variable now. I did not include in. I told you Python does not really check about spelling but consistency. So it was array 3, right? So using np and this. So at the same time, if I print this, you see the output. But let me use 1 stone and kill 2 bit. At the same time, I could have maybe array 4, and I will assign it to np dot arrange. So I want it to I wanted to create an array. Let me just, I wanted to create an array from 1 to 8 with a step 2. So this is how to do it, an array from 1 to 8. Since I wanted that to stop at 8, I will use 9 in range and to be counting it in step 2. What this step 2 means, when it counts 1, it will leave 2 and enter 3, like that. Okay, so I will come out and print. Let me do this to differentiate it. Print using np dot arrange function, and outside there I will call the, just another way of doing it. I'll call array 4, right? Array 4. So let me see if we have error or we are good to. Okay, so I think it's giving us warning. If I run, I should see the error message. Okay, so let's see what the error could be, and we'll invalid syntax perhaps the prints using np dot this. Okay, so perhaps I forgot a comma. That is a very clear error. Of course, you can, I've been telling you about error message. So, and you can see this is underlying where the error is coming from. So if I input a comma here and a comma here, I think the error should be gone now. So if I go ahead and run my code, everything should be fine now. Yes, everything's fine. So to differentiate it, you can see this using from in range 5, 0, 1, 2, 3, 4. We did the range function in our last class. Of course, you know what it does. And this in range, I wanted it to range from 1 to 9. All right, but in step 2, it leaves 2, 3, it leaves 4, 5, it leaves 6, and 7. All right, so that is that, and I want us to look at another method. Someone on mute. Any question? Okay, all right. Once I leave this site, I don't see if someone raises hand or want to ask questions. So if at any point you want to ask question, you can always unmute and call my attention to that. Okay, other than that, I want to proceed. And before this code, I think I should add another. Okay, let me just go ahead.
Can you hear me,
So,
ma? I can't hear you
okay, someone just
again.
unmute. Any question?
Ma, I
All
can't
right,
hear
is
you
she
again.
the
Can you
only
hear me?
one?
I cannot hear you. Hello.
Yes, I'm hearing you. Glory, are you hearing Sandra?
I can hear you.
Okay, so the person, you can leave and join again. I think it's your network since others are hearing me. All right. At another function called random.ran. What that does is that it's a function that creates an array of random numbers. So it will randomly pick number each time you run the code. It will create random numbers, just as the name implies. So let's see from example here. So I will stop at array 5. You can name it anything, but I want that order on. I want it to be organized. So I can come again and say array 5, and I will assign it to np dot random run if it's error, we read from the error message and solve our problem. MP dot random dot run. This should be it. Okay, so I want it to randomly generate 5 numbers. Okay, so if I print, please take note of what is going on here. It's trying to break down in names, array names. You can see the type and everything. So as you look here, I'm keeping this for a purpose, not for fancy. So look at it and try to help yourself. So print what array 5. Array 5. Okay, is there any error? I don't think so, but if there is, you'll see from the error message and fix it. Generates different output each time we run it randomly. Have you seen? Okay, so it has been updated here. So if I want to just try and take note of this number, let me run it again. You see that it will generate another random number. Okay, you could see that it's not the same thing. We add 3 last, so it's the same thing. No matter how many times you run it, it will still randomly generate numbers. Okay, so next I will want to create this MC numpy array. Let me call it like that. So what this function does is that it will create an empty array, but then again it will, if I print it, you will see some numbers, but those numbers are not significant. They are just, how should I put it? They are just arbitrary. Okay, but in the right sense, it's empty. Nothing is there. So let me add a code base and do that. So let's call it array 6, and I will assign it to np. Of course, you know numpy np dot empty, and I want it to create empty 5 plus. So if I run it, you see some arbitrary numbers in some editors. Yeah, these are nothing serious, it's just some arbitrary. Now let me explain that again. So here I've created an empty array of length 5, 1, 2, 3, 4, 5 in the first line using this function mp.empty function. So if we look at the output of the code, you can see that the empty array are not actually empty, that it has been filled with some values. So this is because although we are creating an empty array, NumPy will try and add some value to it, and these values are stored in an array, and these values stored here are not really values, that are just arbitrary and have no significance. Is that part clear? Should go over it. Any question? Okay, you will see. How many of you is doing this with me? Hope you are trying to practice this with me. Okay, so here comes the, I think these are just some of the basic. There are lots you see as you proceed, or maybe I can just drop material. It's just the method application the same way, and you see what it does. So I want us to now quickly talk on something before I forget, which is very important, which is ND array creation. Okay, so basically you could see this thing, like NumPy is telling you the ND array, and you'll be wondering what does it do? What is the function? What is the need? Do you really understand what it does? Yeah, that is what I want to do now. So I told you that this ND array is short for n dimensional array. This n could represent any number, right? Could be 5, could be 6, and all of that. So that is what I want to try and give a very brief explanation on that. So NumPy is not restricted to one dimension, 1D. So if you hear me call 1D or 2D, it's not D, but the D stand for dimension. Okay, so I'll be using most words and aliases. So it can have arrays of multiple dimensions. All right. So the multiple dimension is what we can also call the n-dimensional arrays, or this for short, or this ND array, right? For short. So an array can have any number of dimensions, and each dimension can have any numbers of items. Of course, we experiment that has so many items in it, but the dimensions part is one to deep dive into. Now, for example, a 2D array or 3D array and all of that represents a table with rows of columns. So I want to quickly visualize it with your chart. They can tell you go to the first row. Of course, that is the first bench, the first line of chain. So that is row. Okay, and the person sitting on the second next to the first person, that is row 2. So this is the first row, but in this way, this is row 1, row 2, row 3. So I'm trying to differentiate, sorry, column 1, column 2, column 3, but straight this way is column, going down is row, right? Okay, so for the, I was trying to explain this. So for a 2D array represents a table with rows and columns. You visualize it, while 3D arrays and going forward represents a cube with width, height, and depth. So there are multiple technique of creating ND array, dimensional array. So we will explore some of the method, and some I will leave a material for you to go and read. So let's go, and if at any point you're not hearing me, you can always call my attention to that, because once I leave this page, I don't know what is going on here again. All right. I want to add now to create an n-dimensional dimensional numpy array. Just I don't forget. Maybe from a Python list, just like the one we do here. Maybe we saw what is it called? We did nested list and all of that. Okay, so maybe from Python list, we can use the np array function and pass the list as an argument. All right, so let's see a very simple application here. Before then, I think I should add a text. No, it's at here text. I'll call it ND array. So n-dimensional array. Okay, so I can, let me go with, right, so let's say this is a new one and I want to give it what name? Let me call the just this app one new now, and I will assign it to np dot array. Now to do this, to create a multi dimensional array, that is array that is more than one. Okay, so we could have this. This is usually when you want to create another one, and inside this, I want to have another square bracket depending on the numbers of dimensions that I want. So let me use 2 for now. For this, I want to say 1, 1, and 2, 3, 4. All right. And in here, I may want to leave a comma in a straight line like this and have another box, right? Another square bracket. But just for clarity's sake, I will do it this way. Hit enter. And try to take it here. So in here, I want to leave it for clarity. If there's any error, we'll do it together. But you can do it in a straight line, right? So I want to show you the numbers of dimensions. We start at 4, maybe we could have 9. Do we have 3, 7, 0. Okay, so that is that. And compound prints. What am I printing? Of course, the array, the variable name, right? Act1. Is there any error on my indent? Okay, if there is, the error message guide us and we'll fix it. Okay, there's no error. So this is this. And if you come to Act 1, you see that the shape has changed. You get to the shape method, but that is why I was telling you to put your eye on this, right? You can see that the array, the variable name, okay, is Act 1 and is of ND data type, which is what you are seeing here. And the shape is 2 to 4. I'll come and tell you why it is 2 by 4. And these are the values. You can see this is a straight line, which is the same thing as this, but this is what we have. So it's very clear. Now, this 2 by 4 that you're seeing here, these ones that you're having is simple array, but this is going forward. Because it's more than one, want to call it a 2D array. If it's 3D array, 4, and all of that. So let me explain why it is 2 by 4. So we have two rows here, just like as I was trying to explain earlier. We have 2 rows here. This is row 1, this is row 1, and this is row 2. But how many columns do we have? This is 1 column. This is 1, 2, 3, 4. So each row has 4 items, all right? And each of these 4 items is, call it as what? Row, a column, right? So it's telling you that from our definition that ND or 2D array is what? A table showing you the data in rows and columns. So this, we have 2 rows here with 4 items, and these 4 items are in column 4. So that is why we have 2 by 4, 2 rows with 4 items. Is that clear? Because next we'll be building from here and go forward. Okay. So no question, and I want to do this here. Let me ask. Right, so see here, I want to add a comma in that, have another square bracket, and in there I want to have 5, 3, 2, 2, 19. Is that for 1, 2, 3, 4? Okay. And I will still do something. Watch what I'm doing. Watch what I'm doing. In there, I'll have another square bracket, and I'll say maybe 62, 58, anything, and 20, 32, right? Another square bracket, and I'll have 90, anything in 10, 39, 20. Is that for, yeah? And I will have 74, 32, 17, and 83. Right, so that is that. So look at this now. I'm trying to create a 3D array with two slides. 3D array with two slices, 1, 2. Each of 3 rows. Each slice has 3 rows and 4 columns. This is 1, 2, 3, and 4 column. 1, 2, 3, and 4. So if I run that, see, okay, I think I have an error there. You'll see from our, okay, yeah. So that error is because I'm still trying to build on the, so if I quickly add, yeah, if you see, I know why the error is. I need to just add a square bracket again. So, but let me show you from the error. Setting an array elements with a sequence, right? The request state array as an inhomogeneous shape. Of course, I'm trying to create a 3D array. I'm working on a foundation of 2D array. That's what it's telling you. Shape after 1 dimension. The detected shape was 5. Because I don't need to go the next step. We can explain error, but I know how to fix it. So I'll just come here and add a square. Come here and add a square. I think that should fix it. 1, 2, 3, right? 1, 2, 3, 1, 2, 3. Okay, let's see if there's another error. I think this should correct it, but if another one comes, you will view from the error message. Okay, the same thing, most reasons in cell 1, 2, 3. Okay, that builds it, but this was in 2 slices, right? But I'm still building on 1 slice. So I need to add what a square brackets there to make it 2, 1, 2, 1, 2. You have to be careful with this while building it. 1, 2, 1, 2. And I did not okay, so here is the first one supposed to start with this closes this. So this one should start another slice of array. So if I add that, I made mistake. Instead of adding it here, I had there. So if I take this out and I will close it here as the last part. So this should normalize everything now. I believe 1, 2 with the slice of 2 closes here. 1, 2, and this close. So let's see. Okay, so it works now. So what was that means is that we have 3 rows here. 1, 2, 3 in each, but this is a 3. How should I even say it? Now this is a 2 rows or 2 slices, if I should say. but each has a 3 rows, all right, with what? With four columns, 1, 2, 3, 4. So what I did here was that since I'm having 1, 2, 3, I should have added here. Then this one is for the first one, and this closes the first slice. This opens the second slice. So this is our output. Let's go and visualize it. It will help us do better. So the shape is that of two. See the shape, 2 slices. This is the first one. This is the second one. These 3 are saying that is telling that each of the slices has 3 rows, which is row 1, row 2, and row 3, right? And each rows has, have you seen, has 4 items, and these items we call it column 1, 2, 3, 4. So we have 4 columns here in each of them. So this is our output now, and this is what's from a variable inspector. Any question, let me know if you are lost somewhere, or some reactions to know if I should proceed. Some reactions or questions. Okay, I should proceed. Okay, so I think we've done how many methods? We've worked on zeros method where we fill each year here. We've worked on range method. We've worked on random, and if we created this function now, this function on one-dimensional array, I think it should be possible for us to create a multiple dimensional arrays as we want it. So let me get a new cell, a new code cell. And say R2 equals to np dot 0. Previously, we worked on it with 1. Where is it? See, we have only 1, but I want to work on 2-dimensional arrays, right? So let me use 2 like this. So np dot 0. You saw that we had 1 previously, but this one I will have to create 2, right? Which you'll see the shape from here. Okay, so 2, 3, right? So let me make it a bit descriptive from our print statement. I want to, let's say it's a 2D array. Let me just add this and leave space to it. So print on anchor R2, print R2. Yeah. So this is for 2-dimensional arrays. So if I run that, you see it's filling it with zeros and into, you've seen the shape. It's telling that, yeah, it has 2 columns with 3 rows. So let's do that for also for Palace arc 3, and I'll assign it to np dot zeros. This is done. Let me just accept this is what I wanted to do. So np dot zero, and then again you can see that it is having the shape there is having what 2, 3, 4. All right. So if I hit Control Enter, you could see the shape here. From here, this is for the 2D array, and this is for the 3D array. And you have seen the shape. It's of slice two slice, just like what we have here. So it's of slice 2. With each has 3 rows, and each has how many? 4 columns. So of course you could see that from Act 3 here, 2, 3, 4. All right, so that is that. Everywhere is quiet. My people talk to me. Are you following the flow? Does it look like what's this? Wow. How many people are in the call? 5.
I'm following.
I have Sandra and the rest. All right, thank God you're following. Trust me. Okay. You always have the recording, and I'll drop resources for that. So I want us to look at another concept where we will create ND array with a specified value. This one, ND array. Can you see me? I think my headset is just giving me some sound.
Yes.
Okay, I think it sounded disconnected. Okay, so I forget what I wanted to say. Okay, yeah. So I want to create an ND array with a specified value. All right. So what that means is that next we saw that we use a method 0, and everywhere we filled with 0, or we manually pass in the items by ourselves. But there's a method that we can, use a specific value, and each array, instead of using method, will be filled with that. So let's experiment with that. It won't have stopped me anything from clearing and reusing this, but I want to push this to GitHub so that those who access it, so that's why we're having a very long file and all of that. But all of this file built from this because we've imported Numpy, so everything still comes and pay homage to this particular line. And of course, I told you this MP is alias, so it's not magic. It's what I want to do so that when I send it to GitHub, people will be accessing it. All right, so let's see, it's creating array with specific value. Let me rather pick a text creating array with specified, that as well as specified value. Okay, so I want to hold it.
Design and creative under marketing and
Not just hold everything.
do you understand?
Oh, specified. Right. And let me get a code cell. I can make the name more descriptive. I could say spec value for that for short, and I will assign it to, of course, I have to call np dot. So what does that is the full method, right? Full method. and I want it to create a 2D array for me. So I have to put in under this. What value should we use? Let me give it 2D, 2 by 2, right? And outside that, I will want to give it that it should fill everything with what? With 3, right? Fill everything with 3, and I will print what? Let me make it a bit descriptive. Print array. Then I'll call this variable here, this my 0. So any error, I don't think if there's any error, we read the error message, I will correct it. So let me run it. As you see, it has created a 2 by 2 array, a 2D array with value 3. So if we change this to 5, maybe run it again with 5. We change it to 10. We run it, changes to 10. So this method now helps us do that. So if we can randomly generate what we do here in a 1D array, we can also randomly generate in ND arrays by ND, any number 2D, 3D. So know that this N now should always be replaced by a number. When we talk of ND array, the N should always be replaced by a number. Hope the message I got is not misconnected. All right. So let me get another cell, another code cell, and so I will say what's I will say run underscore gen. That's my variable name, and I'll set it to np dot randomly dot random rand. So what this will do for me is that it will create a 2D array for me and call this in this. So before that, let me even print something. Randomly generated array by for 2D array. Okay. So if I run that, hope there is no any error. If there's error, or you get it from the error message. Okay, so it has randomly generated array and array for us, or 2D array. If you run it again, you see that this number will change. 39 here, 42 here. If you run it again, change 82 and all of that. So that is it. Let me just still use here. I'm grateful 3D array. Run gen for 3D. All right. So np dot random dot rand, and I want it to,
I don't want them back.
2D.
Come on.
Okay, so this is giving me issue because I don't understand it. So I want to create a 3D array with shape of okay, let me pass it to all right, 3D, we get to see. So if I save it,
Then follow here.
it has randomly generated for 2D and it has randomly generated for 3D.
See, you don't call you don't cut come out
If
board. What does that mean?
I do it, you see that the numbers are changed. Of course, I can create an empty 2D array. What I'll do here is this.
You know.
Text rather empty 3D array. So I want to bold everything. And
I have a
it's
question.
okay, please go ahead.
Is this 3D not supposed to display 3 rows?
So it's creating a 3D array with 2 slides. So each
Okay,
having
okay.
2 rows and 2 columns. I don't know if you get 2 slides with 2 rows and 2 columns. Where is that? This, have you seen that? Is I'm telling you, do not look at this, the shape. If you did, it could have helped you out.
Please scroll up again.
Eh?
Please scroll up to where you wrote the mp random.run. Okay.
So always use here. If you okay, so let me go this ones again. If you see 2, the shape is 2, it is a 2D array.
Mm-hmm.
But 3, it is a 3D array.
Mm-hmm.
All right. So what that means is that it is giving you an empty. Okay, this is for random, right? So it is giving you a random like two using 2 slides. All right, with the 2 column. This, where is it? Let me know the one I'm talking about.
It's giving 2 slides with 2 rows and 2 columns.
Yeah. Where?
So what makes it a 3D now? Is it the 222?
See the shape now. Let me. So we see that this part, where is it? See the shape for 2D.
That is 2,
Okay.
2.
Of course. Now, for 2D, where is it? This. Now, see where we have 2 slides
Mm-hmm.
with 2 items each.
Mm-hmm.
We have 2 slides where oh yeah, yes, I've seen it. Now this is how it comes up. It's giving us 2 rows in each. No, this is for 2 rows in each. Then with 2 slices,
Mm-hmm.
and each of them has 2 columns.
2 rows and 2 columns.
So yes, 2 rows and 2 columns divided into 2 slices. Or should I say 2 parts if the slice is what is affecting you?
No, I understand.
All right.
But the confusion, okay.
You still confused?
No. I think you have tried to explain it because you were saying we should do it a 3-dimensional array, and then the result is coming out in 2s. It's not coming out the way the others were coming out in 3s. But you have explained that the 2 slices for 2 columns and 2 rows takes care of that.
So now let's go to something even more important, which is NumPy. Before that, I wanted to work with NT3D, but you can do that. It's just the same. I think we did it for 2D. Yeah, this. So it's just for you to call the method, and instead of this, you feed it with 3 items and all of that. Okay. So we look at what is it? NumPy data type. So what is the data type? We've been doing it since we started, but let me just run through it. That it is a way of specifying the particular data type that we want to store our values. Okay, but in this case, then we saw integer, we saw strings, we saw floats, and all of that. But when it comes to NumPy, and I told you NumPy work basically with an array kind of list. You've seen that you've been working with something that looks like list, but it's an array. I'm bringing listeners because you've been working with list in weeks past, so you could see this. So when we talk about anything in NumPy, I know that we are talking about it in an array structure. Right? I'm receiving some sound. Is there any problem? Messages or what? Okay. All right. So you know that it is for NumPy we deal with array, right? So when I hear me talk about data types in NumPy, just know that the type of data that will be stored in an array. By that type of data, please, your mind should not take it to strings and all of that in NumPy. Just wait till when we get to pandas. Okay. And for that, sorry, I need to give my back. And for that, NumPy has provided us with several built-in data types, which efficiently represent numerical data. Right? NumPy, I told you that is for short for numerical. So some of those, depending on your machine, now please you have to take notes because we are getting into memory management. This is your core machine now, what your system is built on. Okay, so NumPy offers a wide range of numerical data types that are available in Python, because NumPy is a library in Python, and I want to quickly take you to some of those data types depending on your machine. So if your machine is running on 32 bits and all of that, each byte is, if it is like int 64, I don't know if you've ever come across this thing. Maybe you're downloading something, they will tell you for this. So if your machine is 64, know that each byte now in memory, we are not talking about memory management too. So that each byte now is 8. Each byte, let me do like this, 64 was to each byte. Is that it? I don't forget the spelling, either E or no E. So either way, but no, I'm talking about bytes memory. So each byte is 8. All right. But if your machine is of this architecture 32, know that each byte, either byte like this or byte it's E, I've forgotten the spelling, is 4. Take note of that, because if you hearing me talk about 8 and 4 now, you start asking where is it coming from. Now that is that. I need to clear you for your machine architecture. So for the signed, we have signed integer tags with different bytes. Okay, so I just remember that this byte has no E. The E is the one you bite someone with your teeth. Okay, that sounds like that. You forget spellings. Okay, so we have what is called signed signed integer in Python. Why am I forgetting spellings like this? I think that is a spelling now. Integer, is that it? I don't know, but I'm talking about integer. I know what I'm talking about now. Integer types. And we have unsigned, same with spelling. Unsigned integer. I'm not sure if that is meaning of integer in this. Integer type. Okay. So for this part, for the first one, for the signed integer type, depending on that we have int 8. I will apply it in code and you see. So, but just follow it so that when you see it in code, you know where it's coming from. Int 8, int I think the next one is 16. After 16, yeah, int 32. And before we get to 64. So for the unsigned ints, we also have it's represented this way on. Jesus, I forgot it. Yeah, on ints. Yes, on int 8. And on this on now you stand for unsigned though. This unsigned now. This one is signed, this one is unsigned. You see it when we get to after that, after 8 is 16. On int 16. On int unsigned int is 32. After 16 is 32. And unsigned int of 64. Then we have another one. Of course, you know, Numpy has to do with numerical additions only. So we have for floats. I should add floats, so you're not there. Is there any need? But no, there's float. I'll add floats. 32 for floats now. 32 and floats of 64. As that float works. So now this float now is a what is typed with different precision levels. Okay. And then again we have complex numbers. When we talk of numbers, we have the one that comes with sign, like then we have minus. Back then in number lines in school, we have minus, we have plus. Then so sign, and then we have possibles number, which they call it, I think was it old number or something like that. Then for float, of course, you know, with your maybe 4.0 and all of that. Then for complex numbers, we also have complex numbers, short for complex. Complex is for 64, and complex, is that the spelling? Yes. And complex deals with large numbers. So see how it's going from this to this to this, and 1 to 8. I think yeah, 1 to 8 for different positions. All right. So we'll check data types of NumPy array. So how do we do that? In Python, when we wanted to do, if we want to do something of such, we always use this type function, right? Type of what our variable name. Sandra was our popular variable name then, and it will tell us the type. But in this and in Python, we would see, you see how that works. So let me see, go back to my notes. I'm not doing this again. I'm doing data types. Can I edit it? Is it editable? I think it should be editable. Yeah. So data types. data types in NumPy array, right? Let me try and do that. Enter and I'm out. So we want to say good self. No, come down, go up. Have you seen how that's okay? So I'll get to a good self. Still working, you know that on this particular good self, we still have our NumPy. So it's working best. So let's say let me use my name, please, to differentiate. UD. I think we don't have UD here. Okay, we don't have UD here. So UD equals to, just to create NP, calling NumPy now, NP dot, of course, array. And I want to create let's say 2, 5, 55, and what am I doing before then? Maybe 2. All right, maybe 4. Not much, just to check. Yeah, you can always add your comments. We talk about comments, so that coming back you can know what am I doing. Let me say I create an array of integer, and this integer is of integer. Okay, so next I want to check the data type before I print it. Comments now. Check a data type. I will not be doing this, but you can always do this too. So what data type am I checking? I'm checking the data type of UD. Check the data type of UD. Right. So I'll print UD dot data type. This the function. So this D type now will tell us the data type of int. And for your information, my machine is of int. The architecture of my machine is of int 64. This one. So my output might not be the same with your. I'm telling you that so that if you have a different output, my machine architecture is this one. So just in case you have a different output with me, maybe probably you pending, you might also have this, or you may have this one. So since my own is this, it should run. It should give me int 32. Am I even sure that my own is that? I think it is. So let me save that. Is there an error? No, if it is, you check from the error message. Okay, so my own is int 32. Why are you having 3 here? Let me see. And yeah, it's time to make the class interactive. Why are we having 3 here? We've been talking about it from all these to here. Sandra, Glory, and others on the call. Why is it 3 here?
Share your screen. Just share your screen.
Why is it 3 where?
Yeah. Why is
Okay.
my variable vector showing me 3 here? From our code here. Why are we having 3? Everything is
Because
even
you have 3 different ender.
3 words. I don't think we work with rows and columns. You might not see it, but these are 3 columns here. These 3 items are 3
Okay.
words. Yeah, 3 columns. 1, 2, 3, and all of that. And you can see that the data type is of int 32. But there is how you can manually add. Okay, let me not just do that. Let me run more of them.
So you delete project name,
Let me run more of that. Come here and I'll do for maybe on dates, and I'll say np dot array, right? And I'll bring my square bracket. I'll say maybe -2 -4. No, I'm out. Please watch the screen so that maybe if I make a mistake, you can call that. So it's supposed to be inside the box. -2, -5, -6, or -4, and all of that. So I'll print data type of this. I just want to run all of them so that see for floats, I could say floats 1, np, of course, array, and I will bring my square brackets. Floats, of course, 3.0, 4, 4.1. What again should I have? 9.3, and so on and so forth. So I'll come here, and which one we talk about? Sign in. We've talked about. Can I do for complex number? Right? Yeah. Let me do for complex. Com for complex. We assign it to np dots. Let me just accept this. Of course, your complex number comes in this format. So let me print type of. I printed type of UD, type of unsigned, type of floats. Let me print. No need. I'll come here. Yeah. So I'll take out this one.
Okay, so duration,
I'll take my this thing down here. Check data types. Start. I'll add check data types. Okay, so this should give us each individual. So based on my machine architecture, this integer is going to give us in 64. Float is going to give me float 64. Complex should give me complex 128, right? Yeah, based on my machine architecture. Just in case you don't have the same thing with me, you know where it's coming from. Okay, so this is it. I'm expecting question. So depending on either these two now, it's default for me. So maybe you were expecting to see minus int, you not see it, because that is the default for my machine. Might not be the same thing with you here, and all of that. This is, and I'm talking about memory management. So most time going forward, my outputs cannot be may not be the same with your own outputs, of course. Okay, so that is that. We'll be using that. So this is the default one our machine has, and we can have our own, what is it called, our own defined data type, right? Where we manually say, okay, give me for this, give me for this. So in Numpy, you can create an array with defined data type. Now by passing the data type format to it, this dword, this, I think we did it, this function, where is it? Okay, I've not seen it, but I'm looking for this word now. This D type. Let me just type it out. This is the function I'm talking about. So if you use this function, you can manually assign a particular data type to your system. So we are supposed to stop by 1, but I think you guys are enjoying the class and network has just had messages on us today. So let's continue. So I'll pick this and I will have UD1, I have UD, let me have UD2. I'm only one, I don't have another copy of myself. They do. So np dot array I'll call in my square bracket and maybe 1, 4, 7. All right. Please watch what I'm doing. 1, 4, 7. I'm supposed to stop here, right? But no. At here, just immediately after the second square brackets that complement the first one, I'll add a comma there and bring in my d type function. D type, I want to assign my D type to what? To int. I want to assign it to, let me take it down to 32, int 32. All right. So if I print now,
You type 23 instead of 32.
oh, thank you very much. That is the essence of washing my screen. Let me delete all this. Thank you for that, 32. Okay, so I can come here and print let me print array 1 so that you see, then I now come and print the data type. So array 1 and array 1 dot d type. So if it first of all prints this and it will print the type, it first of all prints the array 1 and it will print the type of my array. I just hope there is no error, but if it is, the error message should guide us. Okay. Nobody's telling me. Glory, you are not watching my screen this time around. Where am I bringing array 1 from? And was this UD small letter or capital letter? People, maybe you are tired, you stop the class. Hope this U was small letter. Okay, the error message should still guide us either way. Okay, it is avicing. Okay, it's telling me that is of this 32. Why? The default 2. Can I do something like this? Come here and say np dots this. There are ways of doing this. It should give me 32. Let me try this other way though. Okay, so I think this part is what I just had is not correct. dp dots 32. Is it not supposed to be this? Okay. Still 64. Okay, so I think by default my own cannot change, but this should work. This should work. Lord, can you try from your end and let's see if it's my system
What's the name of this event?
or I'm having error at my syntax, so I know where to correct. Can someone quickly try and let me know the output?
What are you trying to achieve? Is it for it to turn to 32?
Yes, I wanted to convert it. I don't know if there's so much in my system, but yeah, there's something like that where you can manually change the data type to this, just like when we could typecast. But since this is dealing with memory, I think my system does not allow that. So that was why I asked if any of you could try this from your end. By default, my machine architecture is in 64, so I wanted to try convert it to 32. There's something like that.
Okay, because I also my own system too should be 64. But I'm trying in the code now.
Okay, so try and let me know.
Mhm.
Have you tried? Okay, so as you're trying, let me quickly explain our last concept for today. We're supposed to stop by 1, but this one 11. So once you are done with the outputs, you let me know. So there's something called type conversion. I think I should get a text cell first. I call it type conversion. Right, so I'll bold everything here for clarity. And let's do that. So type conversion, just like we did using the when we cast in Python. So Numpy has a built-in a method called as type, and you see how that works. So if I will call this type underscore convert for short. So I'll say np dot array.
Okay, mine has given me 32.
Okay, so yours works. My machine by default is not changing. So Sandra, Promise, and others in the call, you should see. So what I already mentioned that we've gotten to the point whereby my output might not be the same with your own output based on my machine architecture and all of that. So Glory, thank you for that. So for our own, this works. Okay, so to convert this, Glory, thank you very much for that. Okay, so to convert this, we just like we did in Python, can do this here. You can have maybe 2, 3, 4, 1, right? And not a new to please. So I want to convert an int type converts int data type to floats.
Observation, please.
Go ahead.
All right. So when I ran mine the first time, it gave an error message that it did not find UD2. So I just changed the uppercase letter for UD2 and made everything UD2 type.
Yes, beautiful, beautiful. Thank you very much for that. Even me, oh God, why did I notice? I was wondering. You could see this, right? So this went to print for UD somewhere that we did. Thank you for
Yeah,
that. Yeah, so this should be,
UD2.
please be watching my screen, no, be watching my screen so that you can always call my attention to these things. Because I was wondering why it did not work. UD2. Hope that is it. Oh, thank you very much, Glory. Thank you very much. So it's works. So you can even go ahead and do for floats. You can go ahead and do for complex and all of that. I think my complex, let me add one. My complex that time shows 1 to 8, right? So I can change it to maybe 64, just one more. I can call it UD3. Then assign it np dot, I'll come back to here. I'll come back to here. So np dot array np dot array, then I call my square brackets and I will say maybe 1 plus 2 and this, and 2 plus 3 and this, and maybe 3 plus 2 and this. Okay, so outside this square bracket, I should have something like D C type, right? Data type equals to what I would for complex, and I'll set the complex to complex number string, complex of mine was 68 right here. So let me change it to 64. Okay, everything being equal. Please, you can watch my screen just in case I there's typo. So complex is 64, right? Okay, so Glory, thank you for that observation. So you can do the same for floats, just use float and all of that. So let's get to our last subtopic for today. All right, which is type conversion. So I want to convert it to floats here, and say floats. Convert to floats, and I'll assign it to. I'll now call what? I'll now call typecon, right? Underscore type convert, and I now call the method, the asType method, asType, the asType method.
As a question, your role is to read. Why is that?
Then I'll bring in the floats keyword.
So, we are talking about budget.
Okay, so what this particular line does, just like when we converted, we saw in our last class when we converted a list to a tuple and we converted a tuple back to a list and all of that. So typecast, when we change from float to integer, float to integer to floats, we did that. So we want to try that here. So this is what this particular line should do. Typecast floats. All right, so let's print it. Let me print float and then again floats con, and I'll print
Focus on empowering time.
floats con data type. If people are not observing again, I'm tired. I made a mistake here. Nobody called my attention to that. And let me even print this.
What
that you
as
see.
type? What's this?
Now
What's this?
It is a method. It is a method, just like when we saw the zero, the empty, the d type. So it is a method or a function that does what? It is a method or a function that, just like when we use ints in Python and string str to convert from one data type to another. So this is a method in Python that does that. All right. So for before that, let me even print type con and type of. I just hope there's no error, all things being equal to shift one, but if it doesn't, the error message will guide us. Okay, so 64 and float of 64. Mind you, it picks back to my system default architecture built and all of that. So that is that. And here is telling you that it has converted it to float. So this is where you stop from today. Next class is tomorrow. Yes, tomorrow we are supposed to have our class, but this one is the one network couldn't allowed us yesterday. So from next class we look at Python, Numpy rather, array attributes and other subtopic. So for that we will want to call it there.